everyone. Welcome to our presentation about blindness and the amazing things we learn about the brain from how blind people perceive the world. So this is our agenda for the presentation, and I will be starting by talking about an introduction to what blindness is and the different types of blindness. So by definition, blindness is the inability to see or lack of vision, and oftentimes this cannot be corrected. Some common causes are injuries, both infectious or non-infectious diseases, unhealthy lifestyles, or simply by aging. Some treatments include medication, glasses or lenses, surgery, or special types of vitamins. Only some types of blindness can be prevented, but for the ones that can be prevented, common ways of doing so are having regular eye exams, wearing eye protection when needed, and maintaining healthy habits. I won't go fully into depth for time's sake about these different types of blindness, but they include low vision, partial blindness, where some of your vision is impaired, but you still have some ability to see. Some age-related blindnesses. We all know that 20/20 is perfect vision, but you are considered legally blind when your vision is worse than 20/200. Total blindness when light cannot be detected. There are a few condition-based blindness, such as nutritional, snow, and dark blindness. And a common misconception is that color blindness is a type of blindness, but is in fact just a color deficiency.
Okay, next I'll be talking about how often with blind people, their other senses, their non-visual senses, are enhanced. And this type of phenomenon is known as neuroplasticity. There's 5 main ways where we see this: hearing, touch, smell, proprioception, and brain adaptation. For the first 3, they all kind of work in similar ways. Overall, these senses become more enhanced, but each kind of have their own different thing. Hearing is useful for spatial awareness, and also it's one of the ways, it's the main way where, as Gage will get to later, blind people kind of use forms of echolocation to figure where things are. For touch is mainly used for kind of in tactile ways to figure out textures and shapes, and is mainly is crucial for reading Braille. And smell is very helpful for blind individuals to kind of identify people, locations, and objects. And these 3 senses help build together to work towards proprioception, which is also body awareness. And we find that because blind individuals rely more heavily on these senses and cannot rely on visual input, that their proprioception and body awareness is much better than the typical sighted individual. And lastly, brain adaptation. As we've seen in this figure here, in blind individuals, oftentimes their visual cortex is repurposed to enhance these other senses, which is why we observe such a thing as neuroplasticity. So when the visual input is gone, these 2 other arrows for auditory and tactile and also smell become much more enhanced.
So next I'll be sort of talking to you guys about how the biology behind how we actually see. And so basically, I want you guys to take away is we convert light through, we use photoreceptors to convert light into a message that the brain can read. And so the retina is in charge of encapsulating that light, and the optic nerve helps relay that message towards the brain. And the brain is what actually allows us to paint a picture of what we see. It's not actually like that. A picture of a tree, for instance, isn't something that your eyes is manifesting, but rather your brain is taking a bunch of these different light waves and morphing it into one image. And so some of the diseases that are prominent regarding blindness is age macular degeneration. So basically there's a part of your eye called the macula that's very important to vision, and glaucoma, which is essentially when there's a lot of pressure in your eye, and that helps rupture the optic nerve. And so some of the risk factors for AMD, this is the most common disease that you see, so that's relevant to blindness, is of course age. So older people tend to have more years on them, right? So their eyes are naturally more worn out. Gender, what you eat, so your diet, whether or not you smoke. Don't smoke, kids, it's bad for you. And then your genetic background and what kind of medicines you take. And so if you're interested, I want you guys to read. It's not that difficult of a read, but it's helps you kind of get a background on what age-related macular degeneration is and the things that are associated with it.
Alright, and now for some of the cooler abilities. First off, being blind sight. With a quick raise of hands, does anyone here know who Daredevil or Matt Murdock is?
Me, I know.
Yay!
Let's go, that's wonderful. Daredevil is a blind superhero who has incredible awareness of his surroundings, enough to the fact where he can use it to fight crime. While this may seem like fiction, it is not that far-fetched. This is because of the phenomenon called blind sight. Blind sight is the amazing ability for people who do not have conscious vision to be able to sense the emotions of people around them and different obstacles in their views and their way. So what causes blind sight? Blind sight is caused by patients and animals who experience injury in their primary visual cortex. This can also be simulated through a transcranial magnetic stimulation, which is when doctors place really powerful electromagnetics on your brain, temporarily disabling your cortex and your visual capabilities. However, despite not being able to consciously see, they can still sense simple shapes, arrays of lines, objects appearing or disappearing, movements, colors, and emotions.
So the last thing I'll talk about is how blind people can use echolocation to perceive the world around them. So what is echolocation? Echolocation is the ability for an animal or a person to use sound to navigate their environment. So two common examples are bats and dolphins. Bats and dolphins can use echolocation to send out sound waves and interpret the reflections and echoes that those sound waves make to help identify where food is or help them navigate environments in low visibility areas. So blind people can actually use echolocation, and experienced echolocators can distinguish between different materials between objects. They can distinguish between gaps in certain areas. And so this is useful for blind people, say, navigating a home or navigating public spaces where they can have enhanced mobility in these areas. And it's also important to have it for potentially dangerous situations like walking near traffic or walking across crosswalks. It's good to know where things are without being able to see. And so some common sounds that blind people may use are to tap their cane on the floor, snap their fingers, click their tongues, or even hum. And so it's estimated that 20 to 30% of blind people actually learn to echolocate to enhance their abilities to navigate. So in conclusion, what this all tells us is that despite the condition, blind people still find many ways to perceive the world around them, and their perceptions help us learn more about the brain. And here are our sources.